TikTok knows you better than your best friend. Not roughly, not eventually. Within about an hour of opening the app for the first time, it has a model of what you will watch next that is more accurate than your closest friend's guesses. That is not magic. It is an engineering decision. And today I'm going to show you every system that makes the For You page work, from the moment you swipe to the moment the next video starts. Most people think TikTok is reading their likes. It is not. Likes are almost noise. The signal TikTok actually cares about is watch time. Every video you scroll past, every video you finish, every video you replay, every video you mute, every video you scroll back to. All of that gets logged with millisecond precision. Watching a 15-second video for 14 seconds tells TikTok 10 times more about you than tapping the heart button. The full list is bigger than people realize. Watch time, replay count, scroll back, skip speed, whether you tapped the comments, whether you read more than 3 of them, whether you went to the creator's profile, whether you watched more of their videos, whether you shared, and whether the share completed, whether you saved, whether you put your phone down mid-video. Each of these signals is weighted differently. Watch time dominates, likes are a tiebreaker. Why so many signals? Because individually each one is noisy. Anyone can accidentally like a video, but combined, the pattern is unique. About 80 signals captured across about 20 videos is enough to model someone's taste accurately enough to keep them on the app for hours. Here is where it gets interesting. TikTok does not store your interests as a list. This user likes cats, cooking, and basketball. That representation is too brittle. Instead, you become a point, a single dot in a very high dimensional space, usually around 256 dimensions. Each dimension is a learned concept, not cats. Something more abstract, like low-energy animal content with a slow pan. Most dimensions do not have a name a human would use. They are discovered by the model from the data. Every video is also a point in the same space. A video about a kitten on a windowsill ends up near a video about a sloth eating a leaf because both are slow, calm, animal content. They are geometric neighbors. When you watch a video to completion, your point moves a tiny bit toward that video's point. Skip a video, your point moves away. Over a few hundred videos, you settle into a region of the space that represents you. Recommending the next video becomes the simplest possible problem. Find the videos closest to your point. Mathematically, that is a nearest neighbor search in 256 dimensions. This is called an embedding. Spotify uses it for Discover Weekly. YouTube uses it for the home feed. Pinterest uses it for related pins. Most modern recommendation systems do. What makes TikTok different is 2 things: how fast the system updates your embedding, within seconds of every swipe, and how aggressively it explores. Every 5th or 6th video it shows you is not a known match. It is a probe. Watching that probe tells TikTok where the edges of your interests are. Now here is the operational challenge. TikTok has roughly a billion users. There are roughly 100 million videos in the active pool. If TikTok tried to score every video against you every time you swipe, the math would melt. The system is 2 stages: candidate generation, then ranking. Stage 1, candidate generation. From the 100 million videos in the pool, narrow down to about 10,000 candidates. This is done with approximate nearest neighbor search. Your embedding is hashed in a way that puts geometrically nearby vectors in the same bucket. Pulling the right bucket gives you a candidate pool in a few milliseconds without scoring every video. Stage 2, ranking. The 10,000 candidates get scored by a much heavier model, usually a deep neural network. This model takes hundreds of features per video, hundreds of features about you and your recent watch history. It outputs a predicted score for engagement, usually a probability that you will watch the video past a certain percentage. The top scored videos go into your feed. But that is not the whole story. The system also runs a diversity filter. If your top 10 candidates are all sloth videos, it will mix in something different. A freshness filter. Videos posted in the last hour get a boost. A creator diversity filter. No 2 videos in the next 5 from the same creator. And a quality filter. Videos flagged for borderline content get pushed down. The final result: out of 100 million possible videos, the system returns the next 5, tailored to you, refreshed every swipe. The hardest engineering constraint is not accuracy, it is latency. You swipe. The next video has to be loaded, ready, and starting to play in under 300 milliseconds. If it takes longer, you feel the lag, and TikTok's data shows that users start scrolling away within 2 days. 300 milliseconds is not a lot of budget. Let's see where it goes. About 50 milliseconds for the swipe gesture to reach the server. The server is geographically close. TikTok has edge data centers in dozens of regions specifically, so this number stays low. About 60 milliseconds for the embedding lookup. Your 256-dimensional vector lives in an in-memory cache on the edge node. No database call. About 100 milliseconds for candidate generation and ranking. This requires running the neural network. To make it fit in the budget, TikTok precomputes a personalized candidate pool every few minutes in the background. So by the time you swipe, the ranking model only has to score about 1,000 pre-narrowed videos, not 10,000. About 60 milliseconds for the video itself to start streaming. The video file is also cached on the edge, predicted in advance based on what is likely in your feed. Add it up, and you are at about 270 milliseconds, comfortably under the budget most of the time. When the system misses the budget, a network blip, an unfortunately rare video that has to be fetched from origin, you will see a half second of black before the next video plays. That is why those moments feel so jarring on TikTok and not on Instagram. TikTok set the bar. One more system worth understanding: how content gets removed. Every video uploaded to TikTok goes through an ML prescreen, a model trained on millions of past takedowns. If the model thinks the video might violate guidelines, it routes to a human moderator. Most never see a moderator at all. Inside that prescreen, there is a clever tiered response. Videos that are clearly fine get full distribution immediately. Videos that look borderline get distribution capped. They will show in your feed if you actively search the creator, but they will not go viral while the system thinks about them. Videos that look likely problematic get held out of the For You page entirely while moderators review. This is called downranking. It is not a takedown. The creator does not get a notification. The video just does not reach the recommendation pipeline. From the creator's perspective, it looks like a video flopped. The downranking system is the reason a video can hit 100,000 views overnight and then suddenly stop. A moderator reviewed it and it is now capped. The algorithm did not change its mind. The distribution gate did. Here is the uncomfortable part. The system I just described is brilliant engineering, but it is optimized for one thing: time spent in the app. Not your well-being, not the diversity of your information diet, not whether the content makes you better at anything. Just minutes. Optimizing for engagement has predictable side effects. Echo chambers. If you watch 3 videos with a strong political slant, your embedding moves into a region with more of the same. Anxiety content. Videos that produce a small spike of fear get higher watch time than calm content. Late night doom scrolling. The system knows when you usually open the app and will surface videos statistically more likely to keep you past your usual stop time. This is not a bug. It is what the metric the system was given asks for. If TikTok's primary metric were users report feeling better after using the app, the recommendation system would look very different. But that metric is harder to measure, so it is harder to optimize for, so it does not get optimized for. The For You page is one of the most impressive recommendation systems ever shipped. It is also a system you should understand if you are going to use it well. Next week, we are going inside Spotify Discover Weekly. Same family of recommendation problems, very different design choices. Subscribe so you do not miss it. And if you found this useful, send it to one person who thinks TikTok is reading their mind, because now you can tell them exactly how.